Welcome to Manifested Publishers. My names are Mr. Mariga, and I'll be teaching you advanced management accounting, and today we want to develop further that previous topic that we had introduced, known as cost estimation and interpretation, as indicated here. But today I want us to talk about the various types of what? Non-linear method of estimation, where I want to focus more on one of the methods known as what? Learning curve model, which is basically a nonlinear regression model of estimation, where it is used, or learning curve here, it is normally applied when production is manual, and such that the first unit of production compared to the other units of production that follow the first unit being produced will take more time. What I mean by that is, if you consider the time it takes to produce the first unit and the time it takes to produce the second unit and all the other units after the first unit have been produced, you will find that the average time taken by the first unit is always higher compared to the time taken by the other units that are going to be produced. So this learning curve phenomenon here, or the learning curve model, simply takes into account the rate of change that will take place when you produce the first unit and when you produce any other subsequent unit. As production increases and as an employee gets used to work, they become very, very fast. So the time taken by them to produce will automatically do what? Reduce. But it will reduce to such an extent that it will stabilize. And that stabilization, we will refer to it as steady state. So there will be a point that the time taken will no longer reduce. So it will be what? Constant. Why? Because you can no longer improve. Okay? So the learning curve model here, we are saying, is a nonlinear regression model, therefore, that is of the form and y is equals to ax b plus what? Plus 1. B plus 1, or 1 plus b. Okay? Where average cumulative time or cost, that is a total cumulative time or costs. A is the time or the cost of the first production or output. Production or what? Output. That is A. X is your output. Is your what? Output. B is your learning who? Curve. B is your learning what? Curve. That is your learning curve. So your learning curve, basically, that is a general form of the learning curve what? Model. Of the learning curve what? Model. Now, this should be cumulative. This should be cumulative output. We can even represent this diagrammatically or graphically here. How can we present this? This is how we can present this. I want to show you how we present this. You see it practically that way. X1 and X2. Now, if you look at this diagram here, this being the time, you can say this is the time or the cost, yeah, to produce the first unit, to produce the first what? Unit, it takes longer than when you compare to producing the second unit of output, which is going to be what? Shorter. To be shorter. It is to take a lesser time to produce the second unit compared to the first what? Unit. Why? Because of that impact of what? Getting used to doing something. So, if say T1 is equal to 40 minutes, let's say minutes, then T2 is what? 30 minutes. Then your improvement rate, your improvement what? Rate, which is what? The time it has taken, the time it has done what? Taken to improve, or by what rate we have improved. Yeah, you're going to say that it is going to be 40 minus 30, 40 minus 30, then you divide by what? 40 minutes, but that you have to multiply by who? 100. Therefore, your improvement rate, 40 minus 30 and divide by 40, that should be 25%. 25%. So production of the second unit, or the two units that have been produced, has improved by what? 25%. Therefore, we can say your learning curve rate, your learning curve rate will be 100 minus 25, which is equal to 75%. Okay, which is equal to 75 what? Percent. Okay. Let's talk about, can have an example. Can have an example there. So an example, we say for an 80% learning curve, for an 80% learning curve, for an 80% learning curve, the average time. The average time for the first unit of output, for the first unit of output is what? Is 15 minutes. Is 15 minutes. So the average time for the first unit of output is 15 minutes. Then required construct a learning curve table showing the total time and the average time. Compute the average and total time for 5 units, for the first 5 units, for the first 5 units. Then 3, compute the average time for 5 to 10 units. The average time for 5 to 10 units. For 5 to 10 units. Now, for an 80% learning curve, the average time for the first 5 units of output is 15 minutes. Required, construct a learning curve table showing the total time and the average time. Compute the average time and total time for the first 5 units. Then compute the average time for 5 to 10 units. For 5 to 10 units. Let's start by preparing the learning curve table. Your learning curve what? Table. Okay. This learning curve table, basically, we are going to prepare it or to draw it in such a way that we will have the total time taken and the average time taken. The total time taken and the average time taken. Example, we can say for 8 units. You can even say for 8 units here. Now, you will have your cumulative production. That is always your cumulative production. Your average cumulative time. Then your total cumulative time. Your total cumulative time. The average is y, and that is simply what? Y. Now, the first unit of output, is taking how many minutes? 15 minutes. 15 minutes. Therefore, the total time taken by the first unit will be 1 times 15. It is how much? 15. Which is 15. Suppose we double our production to 2 units. Suppose we double our production to 2 units. The average time that is going to be taken by the first 2 units, you expect it to reduce by how much? An 80% learning curve, which will simply means you're going to take 80%, you multiply by 15. 80% you multiply by and 80% by 15 is how much? 12. 12 minutes. So on average, the first 2 units are taking cumulatively how much? 12 on average. Then the total time taken by the first 2 units will be 2 times 20 times 12, which is what? 24, which is 24. We double our output. We double our output. We're going again to take how much? 80% times 12. 80% times who? Times 12, which is 9.6. So the average time of the first 4 will be 9.6. So the total time will be how much? 38.4. 38.4. Okay. The first 8 units, 80 times 9.6, 7.68, 7.68. So the total time for the first 8 units is 61.44 with an average of 7.68 minutes. With an average of 7.68 minutes. Now, one of the assumptions of learning curve is that we double what? Production. We normally double what? Production. That is why the first unit, then we have doubled again to 2, doubled to 4, doubled to 8, and so on and so forth. Alright. That is the first part of that question. That is the first part of that question. The second part of that question, part B, we want to get our average and total time for the first 5 units. For the first 5 what? Units. Okay. You know that your average time is AX power B, where A is the time of first production. A is the time of first production, which was how much? 15. X will be 5 units. B here, which is your learning curve index. B is normally your learning curve index here. And your learning curve index is normally calculated by taking your log learning curve divide by log 2, divide by log 2, divide by log. So this will be log, you divide by log 0, log 2, divide by log 2, divide by log 2. So log 0.8 divide by log 2, 0. So therefore, the average time of the first 5 units utachukua A 5 negative 0.3219. So this should take 8.9345 6 minutes on average. The total time Y, the total time Y will be given by AXB plus 1 or 1 plus B. This is your total time. And how will you calculate your total time? You will say that y is equal to the time of the first unit, which is how much? 15 times. You're producing 5 units. Your log of learning, your learning curve index is negative 0.3219 plus who? Plus 1. Plus 1. So on average, cumulatively, the first 5 units should take a total of 44.67 with an 80% learning curve. It basically means that they are improving what? 20%. Where on average they are improving at a rate of what? 20%, with an A, which means it is an 80% learning curve. The first 5 units will take 44.6 what? Minutes. That is the second part of that question. Let's go to the third part of that question, which is the average time. The average time for 5 to 10 units. The average time for 5 to 10 units. The average time for 5 to 10 units will be given by the total time of 5 to 10 units divide by your units, which is 5 minus who? 10, which is 5 units. Okay, so let us get the total time of the first 10 units. The total time of the first 10 units. You know that the total time will be your 15, which is time for the first unit, times 10 times 10 units, raised to learning curve index plus 1. Learning curve index plus 1. Time for the first 5 will be what? 15 times 5, negative 0.32194 plus what? Which basically means what? This is still 44.67 2 minutes. Log 0.8 divided by log 2 plus 1. Raise that to power 10. 10 raise that. Then times what? Times 15. 71.476 minutes. Therefore, your average time for 5 to 10 units. 5 to 10 units, what will you say? You take the difference between the time taken, the total time of the first 10 and 5, divide by your units, which were 10 minus 5, which were 10 minus 5. So on average,
5.360896
minutes. So the average time for between 5 and 10 units is 5.360896 what? Minutes. Now, suppose they asked for the time for the 5th unit specifically. What if they asked for the 5th unit? The time for the 5th unit. For the 5th unit. Now the 5th unit here, we're going to take the 5th unit minus the 4th unit. The 5th unit minus the 4th unit. Why? Because you want specifically that 5th unit. Okay? So what will you say? The 5th unit will be 15 times 5, 0.3219 plus 1 minus the 4th unit. The time for the 4th unit, it is 15 for 0.3219 plus 1. So let's see this. We want to calculate exactly the 5th unit. We had an 80% learning curve. This is still 44. Divided by log 2 plus 1 for is to be answer times 15. Therefore y5 672. So the time for the 5th unit is how much? 6.272 minutes. So with an 80% learning curve, where your first unit is producing or is being produced in 15 minutes, the time for the 5th, specifically the 5th unit, will be 6.272 what? Minutes. Now, if they asked for the 6th unit, but they tell you that you had steady state. Steady what? State. Steady state. Now they mention what? Steady what? State. Steady state simply means that there is no more improvement that can be made. There is no more improvement that can be made. So you cannot take any less time. Why? Because you have now stabilized. Okay? So therefore, it basically means that all the other units that will be produced after the steady state, the time or the cost of those units will take the time or the cost of the unit that was produced before steady state. This is what I mean when they tell us that the steady state applied from the what? 5th unit. You will calculate the time of the 5th unit, which in this case we've seen is how much? 6.6272 minutes. Then all the other subsequent units that have been produced or that will be produced will take how many minutes? 6.272 minutes per unit. That means the fifth will take 6.272, the sixth, the eighth, the 10th, even their millionth will take how much? 6.272 what? Minutes. Why? Because you can no longer improve on this particular time. You have reached a stabilization or a saturation point where now you have hit top speed, which is taking how many minutes? 6.272. This is how you deal with what? Steady state, where there is no more improvement. Here there is no more what? Improvement. You can no longer improve. Okay. Alright, that is steady state. Now with that, I think we can do a question. We can do a question. That was just an illustration question. So we can go to our past papers, our Casneb referral past papers. Let's go to April 2025. Question 4C. Question 4C. Question 4C. Matrix, or rather Matrix Motors Limited, is a leading producer of high quality executive motor cars. The company is developing a new model branded Zillion that is expected to be very, very advanced. Additional information: Matrix Motors Limited expects the manufacture of the first car to take 72 assembly hours. It is anticipated that there will be a 90% learning curve that will continue until all 110 cars have been produced. Direct labor hour is paid at a rate of 30,000 shillings per hour. Direct material costs are expected to be 3.75 million shillings per car. This will apply to all 110 cars produced. There are no product specific fixed costs associated with this new car. Matrix Motors Limited is going to use a target costing approach for the new car model. Based on the market research it has undertaken, Matrix Motors plans to sell each car for 6.4 million. Matrix Motors requires a target profit margin of 25% of the selling price over the life of this new car model. The learning curve index for 90% learning curve is negative 0.152. Calculate the value of any cost gap between the target cost of 110 and the expected cost of 110. Alright. So let's determine the cost of those 110 what? Vehicles. You can start by determining your labor hours. We will determine our labor hours, keeping in mind we have a what? A learning curve. Labor hours computation or determination. Now with learning curve, we want 110, so it's the total time. It will be AXB plus who? Plus 1. So the total time will be X is 110. A, remember, it represents the time of the first unit of production, which is 72 hours, times you want to produce 110. Your learning curve index is negative 0.152 plus what? Plus 1. Plus 1. Let's see the labor hours that the first 110 units of output will do what? Will consume. Plus 1. 10 raised to that answer times the first unit was taken 72 hours. So the 110 units will be assembled in 3876.38 what? 7 hours. Okay. We know to determine our labor, our total cost, we simply take it is your direct materials, you add your direct labor, and your overhead cost if they exist, or any other costs that may be there. Your material cost per car is 3750. And you are producing how many cars? 100 and what? And 10 cars. Your labor cost will be 3876.387 hours. You multiply by your labor rate per hour, and your labor rate per hour was 30,000. 30,000. Then we go and identify whether we had any other cost. There are no product specific fixed costs associated with this car. So let's identify our costs. This is for 10,500 million. $116,291. Then you add the cost of materials. It will be 528,610. That is your cost of manufacturing the 110 watts vehicles. So this is your cost expected. To determine our cost gap, we will say there is a difference between your target costs and your expected costs. And your expected what? Costs. When you produce 110 vehicles, your expected cost is there, but we need to determine our target costs. Our target costs be given by your target selling price. You subtract your target profits. Subtract your target what? Profit. Okay. And they were saying, note number 6, Matrix Motors is going to use a target costing approach for the new car model. Based on market research it has undertaken, Matrix plans to sell each car at how much? 6.4. Then Matrix Motors requires a target profit margin of 25% of the selling price over the life of this new car. So our target selling price is 6.4 million per car. You subtract your target profit, and your target profit is 25% on selling price, but you know your selling price is how much? 6.4. So therefore the target cost per car, is 4.8 million per car. Therefore, your total target costs or your target costs for 110 cars will be 4.8 million. You multiply by 110, which is 528 million. So therefore, your cost gap will be a target of 528 against an expected cost of how much? So your target gap is 79,610. That is your cost gap, the cost gap. So basically, which is the difference between the expected and the target, or the actual and the target, is a difference of 791,610 compared to what the company had done, what had budgeted or had targeted to incur. All right, that is April 2025 question 4C. That concept there of learning curve incorporates, it is incorporating target costing, which in itself is a topic in advanced management accounting, specifically known as pricing what? Decisions, known as pricing decisions. It is a topic in itself. Now,